We are the OK Fellas, and this is our How Do They Do It construction presentation. So for our project, we'll be presenting Highway Earth Movement. Our 4 group members consist of myself, Ethan Tinsley, Sam Johnson, Alex Myers, and Peyton Wesselman. An introduction into Highway Earth Movement. Highway projects are usually federally or state funded, and they often require mass amounts of preparation, which result in pre-construction phases that take years. Site logistics are extremely important, often requiring detailed planning and scheduling. Efficiency is key at these long-term projects, and one way they can maximize efficiency is balancing cut and fill. These projects often face a lot of challenges, whether it's weather and soil conditions, steep embankments, site accessibility issues. Next, I'm going to hand it off to Alex, and he's going to present Mountain Parkway Project.
To study highway earth movement, we visit the Mountain Parkway project near Campton, Kentucky and the Red River Gorge area. The current goal of the project is to expand the 2-lane highway to a 4-lane highway, all while keeping the roadway operational during the time of the project. The Mountain Parkway project has been split into several phases, with the first one being completed in 2013 and the current phase to be completed in 2026. The main delay concerns are from weather and rain, from traffic incidents happening on or near the project, and from unmapped cemeteries that the construction crew could potentially come across during the project. For a several-mile-long, multi-million-dollar project such as the Mountain Parkway project, it's imperative that the design team and the construction crew are on the same page when it comes to limiting the budget and keeping the project moving. For the design team, it was key that they focus on the local environment and right-of-way in order to limit the amount of purchases and alterations that were made to the environment and community. For the construction crew, they focused on limiting the haul distance to under a mile within the segments that we visited and reusing crushed rock when applicable. Proper cooperation between the design team and the construction crew can lead to the reductions as seen in the table on this slide. These reductions were from the first section of the Mountain Parkway project that was completed in 2013. The reductions created by the design team beforehand and on-site by the construction crew led to fewer labor hours used, fewer materials used, and less of an impact on the local environment and community. All of these help keep the budget down and keep the project moving.
So here's the process model we developed. The process model in construction terms is a deterministic representation of a real-world situation, or the framework for construction activity. For our process of highway earth movement, we used an excavator, a dump truck, and a wheeled loader. We used circles to indicate cues and rectangles to indicate actions. The logic goes something like this. An excavator digs from the soil, loads onto the dump truck, and repeats the cycle. The truck receives load from an excavator, hauls it to the dump site, dumps it, returns it to wait in the truck queue, and the cycle repeats. The loader loads from the pile, dumps it at the dump site, returns to get in queue for another truck, and the cycle repeats. It's important to note the direction of the arrow from each soil pile represents the direction of material flow.
Some safety hazards within our heavy highway earth movement operation included falling objects, heavy equipment operation, material handling, dust and other particles, and PPE necessary for this project would include gloves, steel-toe boots for heavy lifting materials, as well as a hard hat for falling objects and masks to protect from any airborne particles such as silica. Here are the relevant plans and specs for our heavy highway earth movement operation. These included the standard test method for particle size analysis of soils, as well as the standard test methods for the liquid limit, plastic limit, and the plasticity index. And lastly, the one-dimensional swell and collapse of soils. These are important because they allow us to gauge things for such as slope stability and what's necessary. Here you can see the safety mitigation techniques that were used on our project. These would include things such as preliminary meetings as well as regular safety auditing. This is important because it allows us to improve the safety on site. The traffic barriers were instilled in order to ensure traffic control safety, which was a big safety mitigation technique used on this project.
This shows the main equipment that was used on the construction site, the first of which is the dozer. There are a couple types of dozers used on the project, the D10 model being the largest. This model has the ability to move more earth, while the smaller dozer, the D6 model shown below, provides better fuel efficiency and is the better option to move smaller amounts of earth. Next is the excavator. The excavator used was a CAT 352 model. This model was most used on the project as it provides extensive safety features and good fuel efficiency compared to other large excavators. Next is loaders. Both models were used significantly on the project. The 992 is larger with a capacity of up to 32 cubic yards, and the 966 model is smaller but provides better fuel efficiency and versatility. There aren't usually too many errors with this part of the construction process. However, equipment breakdown and mistakes with grading and calculations are possible. This can be solved with better preparation and equipment management on site.